Hi my friends, today we'll create the last of 3 parts: drive lever, then a gasket and 2 axles to create an assembly, and then we'll study how this assembly works. The other 2 parts are hinges body and valve lid, and they were presented in my previous 2 tutorials. Today we concentrate on the 3rd object, this one, which is a handle. Its drawing is this. There are some small difficulties with this contour, but we'll create in order we'll create the part in order by using this drawing. Good. Let's start with creating this part. In the plane XY, we draw some lines, arcs, as you can see here. By using methods you already know. If you study all my tutorials, we have no time to repeat. Always everything. Yes, this is the first contour. This point is coincident with the center point. This arc is equal in radius with the other one. There is a non-tangent connection between these two. These 2 points are coincident, centers of the 2 arcs. Dimensions. This is 10. Everything is scaled now. Home. The angle is 40 degrees. And this dimension is 60. Aligned 60, as you can see. Good. Other dimension is the distance between these 2 centers of 38. And one dimension is missing, but I don't know which one. Let's see. Apply. Oh, the radius. I forgot this radius, which is 25. Okay, now it's fully constrained. Finish sketch. F6. You see the thickness is 5, but we'll use the thickness of 8 in order to have this thicker arm, and then we'll cut here. So 8 is the thickness for the moment. 8. Okay, we create another plane at a distance of 13, yes, to be here on this face, and we'll create the other arm by projecting this one and continuing with a protrusion. This. Okay. Plane. F6 sketch F7, not F7 but project all the contour, F7 to see that contour, and then we create a full circle here, and we draw that protrusion. Keep pressed the button and you have a tangent. Keep press the button and you have an arc. And then go back to the circle till you see tangent mark. And then apply tangent also here. The same vertical for these two centers. A radius of 9 here. And a distance of 60 between the two circles. 60. Now we trim using split this circle in parts to make these two as construction lines, and also this construction. We split also this line to make this construction, and we make construction this line because we draw a new line shorter than this shorter line. Finish sketch, extrude, also 8 in this direction. Okay, visibility F6. We continue with this connection between the two arms, which is dimensioned here. As you can see, there is a dimension of 32 for this point and a line at 30 degrees. The other line is parallel 8 millimeters. Okay, we use this face F7. We draw a line from a point here to this direction, and we dimension it to see where it is placed, that 32. We project the x-axis x, this is x, and we make this construction to have no problems. Dimension 30 degrees here. Another an offset of this line to 8, and then trim, and okay. Now we extrude this area between the two lines to the part. Okay, F6. This is the main body. We continue by placing two holes, 8 and 11. This face, this center, 8 plus this face, this center, 7. Not 7, 11. Okay, good. Next is a new sketch in a mid-plane between this and this. We select this plane, we select the plane, F7, and we project lines. This face, everything on this face. Okay, and then extrude. You see the dimension 19 is this dimension instead of 13, and it is on the center midplane. Select sketch. This is the sketch, symmetrical, 19, and cut. Okay. Now this is 5. Let's see. M from Monaco is measure. We measure from here to this line, and this is 5. Yes? Good. Next is this protrusion axle, which is continued here or mirrored, with the dimensions, as you can see, 18.2 to the peak, yes, this point, a radius of 0.5, dimensions of 8 and 4.5. Very important, each of them. We have to be careful with this symmetry axis here, which connects 3 points. This one, or the center of the arc, this one, and the midpoint of this arc. Yes, to be symmetrical, it must be it must connect all these 3 points. Good. Face, circle, with the radius of 4.5, and the distance of 18.2 from this center, 18.2 two lines. One is vertical to a point somewhere, and the other is horizontal, is sloped. Yes. Trim. But let me place dimensions before to trim. Project geometry, x-axis, construction, angle of 8, dimension of 4.5 between this and this, 4.5, dimension here of 8, and we draw a line between this point after we trim. This and also this, because it is not, this arc is only on this side. A line, construction line, from this point to this point, midpoint, then not construction, not line. And we apply coincident between the new line and this center. Now we place that dimension of 8 and 18.2 is not here. Dimension from the center to this point, 18.2. There is only one dimension needed, which is the radius of the arc, 4.5. Now we have fully constrained sketch, and we apply that fillet of 0.5 to this corner. Okay. What is the dimension of the extrusion? It is 48 minus 5 minus 19 minus 5 divided by 2. Yes? So, extrude. This is to be extruded on 48 minus 19 minus twice of 5 divided by 2. Okay, then mirror of this last feature, extrusion, about the midplane. The midplane is written here, midplane, between this. Okay, you see this. If you have no description here, you can edit the model by using View, User Interface. This is the model browser. If you lose this because you clicked here, you have it here. Yes, this is the model browser, for you to know. The last thing to do about geometry is this. All dimensionless fillets are 2. I suppose there is no any other missing feature. It seems to be no problem. So let's apply fillets everywhere, as you can see, but in 2 steps. Or 3 steps. Plus 1, 2, 3, 4 edges. Everything, almost everything here is with radius. Okay, this is the part, my friends. Let's apply material, steel cast as usual, and the general aspect of steel cast, and we select some faces to be machined. Yes, and also the end to be polished. F6. This is the part. Let's see what are its data. This is the dimension. Okay, we save this as drive level after lever, excuse me, after we made it in the tutorial. Save. Now we have to create a gasket to be placed in the lid. This is the gasket. This is the drawing. Let's use these dimensions to create that gasket. We have a point of reference which is placed here, and we have to be careful with it. Let's create this profile and then revolve. Yes, this plane, line, perpendicular here. We know some dimensions because we created the part valve lead, which is the place where this gasket will be placed. We project x-axis, construction, and y-axis as a center line. We place this point on the horizontal, so select the point and select the horizontal. Then angles, we start with angles. This is 70, as you know from modeling the valve lead. This is 14 from the hinges body. This is 15 and this is perpendicular on this, and there are two parallel, these two. This already exists from construction. Okay, other dimensions, 4 millimeters aligned, 6 millimeters aligned, and a point placed on this line at a distance of 3.5 from the horizontal. 3.5. This point is placed at a diameter of 44. Look, almost 44 is, and this is 30. Almost 30 it was. Good. Only one dimension is remaining, and this is 6. That's all, fully constrained. Finish sketch, revolve. Okay, material is rubber, but rubber silicone. This is too black. I don't like it. I want to be rubber silicone and version 1 of the general aspect. Good. F6. We save this as gasket after we did it. And the tutorial. Okay. Having all these elements, we have to create only the two axles. I don't create them, they are very simple. You will understand when we create the assembly. Let's create the assembly. Standard millimeters IAM. We place we select from this tutorial, we select hinges body, but I want to place it somewhere like this. Yes, this is the point of view, and I want to have this as a reference. Oh, and the reference, set current view as home, fit to view. You know this. Everything I do now, if I click on F6, it stay here. I have to place it in the space. Yes, the axis of the part, no, faces. This face is with this face. Yes, I apply constraint and flush for this plane with this plane. Apply for this plane with this plane. Apply, and for this plane with this. Okay, now this is grounded. It cannot be moved. If I press the wheel, I can move the picture, but if I press the left button, I cannot move. Yes? Good. We place then the valve lid after. This is. We place the drive lever after. We place the gasket after, and the two axles which you must create for yourself. They are not necessary for assembly. They are necessary for us to place parts together, connecting with axles. Okay, now the first thing is to place this gasket and this lid. I constrain, but now I have to rotate this. Yes, rotate freely, free rotate for this to be reverted. So escape. Now axis, this axis with this axis. Okay, now I move it a little to place the point, center point of this circle to the center point of this circle. You see, this one. Now the gasket is placed in position. Look at it. Yes, inside the channel in the lid. Okay, good. Now constrain this axis with this axis. Apply. Then the symmetry plane of the lead, this is the lead, symmetry plane is XY, over the symmetry plane of the hinges, which is also XY, but not that too, because it is not possible. Center point. Once again, constrain this plane of the lead with the center point of the hinges body. Apply. Same for this. Axis on axis. This is the drive lever. Then apply. Let's go to the drive lever, the plane XY with the center point of the hinges body. Apply. Okay, now we can make anything from the point of view of Inventor without axles. Yes, we can study everything, no problem, but we place axles to have no empty holes there and to be reasonable in the mechanical way. Yes, so I apply insert and this to be placed here. We are sure about this is not good. This is not the center point. Yes, apply here. This is okay, and we have to change the position on this direction to of the drive lever. Drive lever is this second constraint we delete, and we constrain the mid plane, this mid plane of the drive lever. You see, this is the with the center point of hinges body. Okay, this was not created symmetrical like the other two. This is why. Well, now the short axle is bad placed. We delete this insert and we get it out to place in a proper position. Constrain, insert this, aligned with this. Now is okay. Apply. The other one is the axle long, which must be fitted here. Okay, F6. this is the assembly at the beginning. Now we want to study how this assembly works. The lid must be closed and the drive lever must create this movement. To make this, we make what we already know from the Malta drive in my previous format tutorials. Let me apply a color to this face, for instance green. Green, polished, and another color to this end, for instance orange. Save. You see, they must come together to close the hole. Yes, this is a hole which must be closed by the gasket inside the lid. As I said, we use a procedure we already know from the Malta projects in my former tutorials, which means that we select these two bodies. I selected the lid and the drive lever. Then I apply contact set because I want to study the contact between them. These two are in my new contact set. If I close the deployment of the browser, you see very well this. Yes, they are special. They are in the attention of the inventor. But this is not enough. Yes, nothing is changed. If I want to use this selection, I activate contact solver. Now Inventor is very well dedicated to see what happens when we move parts. And you see, yes, that when I move a part, the other one is also moving at the contact. So we rotate the handle till here. Yes, and this can be made. I don't have here in attention the gravity. Yes, this is already always, not already, always in contact with this because of the gravity. Yes, this is the normal position of this assembly. And this is the moment when it closes. Let's make another thing. Let's apply view, half section view, and select this plane XY. Okay. Now we see the gasket. Yes? Oh, the gasket is placed wrong here. Yes, it is placed wrong. Let's select the gasket. Let's eliminate its mates. Delete. Let's move it outside. We rotate it in position. We rotate, free rotate. So now it is cutted by by the plane, you see. So I apply constraint axis, this axis with this, not the axis of the lead, with this, apply, and then I move the gasket inside the lead to find its position. This face let me open the device to have visibility, and now constrain this conical face with this conical face, apply. Not good. Delete and make what we did before. Constrain the center of this circle. You see which one to be there is no distance. Now it is. You see, I have to see each one elements. Constrain this point, the center of this circle, with this point. Now is okay. We look from the side. We move this to the drive lever. We rotate it to be together. Nothing is changed when we think about the contact set. Now we can see very well what happens here. Yes, when I rotate the drive lever, as you can see, there is a moment when they come in contact here. Yes, the rest of the movement, which I'll apply now, is dedicated to compressing the gasket onto the face. Yes, look, this is compressing. Eliminate. Now you see very well here. Yes, the gasket is inside the body. I don't want, I cannot create the compression itself. I only show you the situation. Yes, this is the situation. Okay, now you have all the image. I go back to the half section view elimination. From here, end section view, and we know that now the gasket is in contact with the hinge's body, and the next movement is only compressing the gasket. Very interesting situation. That's all for today, my friends. Thanks for watching. Bye bye.